section is just what you were doing a few minutes ago, okay? So where it's asking me to find the GCF of the two numbers. The reason GCF is important is because we're going to start using it for something called factoring, okay? And factoring means to break something down into its factors. So, for example, when you make a factor tree, let me give you a really easy number to make a factor tree for, like 6, okay? You do a factor tree, you do 2 times 3. I just factored 6 because I broke it down into 2 things that multiply to make 6. What we are going to do here is we are going to take each one of these expressions and write them as something times something. And in this first type of factoring, because there are a lot of different ways that you can factor, this is the first one that we're going to talk about. In this type of factoring, it's really like doing the distributive property in reverse, okay? So like look at the first one, 6x plus 3. What is the GCF of 6x and 3? What's the biggest thing that goes into 6 and 3? 3. Can I take out any x's? No, because the 3 doesn't have an x, right? So all I can do is take out a GCF of 3. Okay, so this number here is the GCF. Now I'm going to add another step on because you've already done that step. You know how to do the GCF part. What we are going to do is figure out what would be left over if I took that 3 out of each one of those terms. And when I say take it out, I mean divide. All right? So if I took 6x and divided it by 3, what would I be left with? 2x, right? And if I took 3 and divided by 3, what would I be left with? 1. Okay? Now look at this. Do you see that if I took that 3 and did the distributive property, it would take me right back to this? So really what we're doing right now is like the reverse distributive property. It's like we're pulling the number back out. Does that make sense? Let's try number 9. I'm just going to jump around a little bit. So we have 3n cubed, 12n squared, and 30n. Let's look at the numbers first. 3, 12, and 30. What's the biggest thing that goes into all 3 of those? 3. And how many n's can I take out? Just 1, because the smallest number is this 1.
So wouldn't it be a negative? Like,
I'm just a good thought on that. I guess I could make it a negative 3. What I usually just do is leave the negatives inside the parentheses. Okay? So I wouldn't worry about pulling negatives out right now. So I'm going to make that a 3. And then does it make sense that I can only take 1 n? Because I need what they all have in common. And so the most I can take is 1 because this one only has 1. I couldn't take 2 because that one doesn't have 2. It only has 1. Okay. So if I take 3n cubed, let's take just the 3 first. If I did 3 divided by 3, what would I be left with? 1. And n cubed, if I took out an n, what would I be left with? Okay, except I'm going to write it as n squared. Right? N to the third, if I took an n, so n to the third is n times n times n. If I divided out one of those n's, I would be left with n squared. Okay? Minus, when I take the 3 out of the 12, what would I be left with? 4. Remember when I say take it out, I mean divide. And then if I took an n out of n squared, what would I be left with? Just 1n. Minus, all right, if I take 3 out of 30, be left with 10. And if I took the n out, would I have any left here? No, right? So I'm just going to close that off. That's my answer. And if I took that 3n and redistributed it, that's the way you can always check your answer. If I did the distributive property out again, I would get back to this. Let's jump down to number 7. All right, start with the numbers. 10 and 15. What's the biggest thing that goes into those two? 5. Yep. How many x's can I take out? Just 1, right? Because this one has 2, but this one only has 1. So the most I can take is just 1. How about y's? Can I take out y's? I could take out 1y. Yep, so I'm going to take out 5xy. parentheses. What do I get when I take the 5 out of the 10? 2. I'm going to take out 1x, so I'll be left with 1x, right? And then I'm going to take out a y. Now that one only has one y, right? So I don't have anything left for the y's. I'm just going to leave it as 2x minus, what happens when I take 5 out of 15? 3. I'm going to take out 1x. Now this one only has 1x, so that means that I don't have any left, right? And then take out 1y, which means I'll be left with 1y. That would be it in factored form. Tori? Yeah. How you feeling on that? You want to do one more together? No, you feel okay? Okay. Your homework assignment then is to just finish the bottom of this page. Okay? So I did 3 of them for you out of the 14. The other 11 are for you to do for homework. You don't have to go back and do the top of the page. Okay? Just that bottom part.